In the my class that we concluded about the nuclear part, right? So as per the syllabus, let us see what is the molecular part that we need to look at. Okay, once I will go through that part, then let us see. So what are the things that nuclear part we need to cover? Then this from here to here is the nuclear part. Okay, so I have not covered this Frank Condon principle and Born-Oppenheimer. So these approximations are just you can look at those concepts up to here. Nuclear magnetic resonance, that is what is I introduction, and electronic spin resonance. Those have introduced these concepts. Then up to Stark effect, Chenbach effect. Morning class I discussed about this hyperfine splitting rate. That is what. So I have not discussed this chemical part. So let us leave this these two concepts. Look at the molecular part. Okay. So electronic and rotational, vibrational Raman spectra of a diatomic molecule. We need to look at electronic spectra, rotation spectra, and vibrational Raman spectra of a diatomic molecule and their selection rules. Then with this, we can complete the molecular spectra. Then we can go to the stimulated emission and AB concepts of the functions of lasers. So here in this part, in molecular part, that we are going to look at the concepts like um, mainly rotational, electronic, and vibrational parts. Okay, so that is the part. The types of molecular spectra. Firstly, we are going to look at molecular spectra. Molecular spectra. Molecular spectra. See, in this molecular types spectra, there are types of spectra are there. Types of molecular spectra. Types. One is rotation spectra ಒಳಗೆ ಮೂರು ಬರ್ತಾವೆ, ಎರಡು ಬರ್ತಾವೆ. One is pure rotational and another one is vibrational rotational. So here types are first one pure rotational, pure rotational. Second one is vibrational rotational, vibrational rotational, rotational. Then next is this is the first in first ಒಳಗಡೆ main ಒಳಗಡೆ. Second one is electronic spectra, electronic spectra. Fourth one is Raman spectra. That is third one is electron spectra, and then the third one is Raman spectra. Raman spectra. Then these are the things mainly they are given in the syllabus for diatomic molecules. For diatomic molecules, mainly questions will come from only these. Actually, ಅಲ್ಲಿ ಇನ್ನೂ ಬರ್ತಾವ್ರಿ. Nuclear magnetic resonance ಅಂತ ಒಂದು ಬರ್ತದೆ, ಇನ್ನೊಂದು electronic spectra resonance ಅಂತ ಒಂದು ಬರ್ತದೆ. ESR and MSR. ಇದು ಸದ್ಯಕ್ಕೆ ಇವತ್ತೇನು ಡಿಸ್ಕಸ್ ಮಾಡಂಗಿಲ್ಲ. For only mainly we are going to discuss about Raman spectra, electron spectra, vibration spectra, and rotation spectra. So what exactly the first term, that is pure rotation. Okay, 1 minute. Raman spectra. This Raman spectra, there we are going to have the actual laser part. In that, before laser part, this is a vibrational and electronic spectra. Okay, we are not going to discuss about this electronic spin resonance. Even you can hear about it. Electronic spin resonance and nuclear magnetic resonance. So syllabus ನಾಗ ಐತಿ, ಅದನ್ನು ಹೇಳ್ತೀನಿ, ಇದಾದ್ಮೇಲೆ ಹೇಳ್ತೀನಿ. ಓಕೆ, ಹೇಳ್ಕೊಂಡು ಅದನ್ನ ಹೇಳ್ಕೊತೀನಿ. Okay, see, so we will continue this one as much as possible at the molecular spectrum. Okay, first one, let us discuss about what we mean by pure, and moreover you know what we mean by molecular part. So when you are going to have more than two atoms, more than two atoms part, more than two atoms, then you can have, it's a combined property of two atoms, then that we define as a molecular spectra. Molecular spectra. Okay, molecular spectra. Is that clear? Now mainly when it comes to the pure rotational Pure rotational spectra arises due to the change in the rotation state of the molecule. First one is pure rotational spectra. First one is pure rotational spectra. Pure rotational spectra. So in the case of pure rotation spectra, it is arises due to the rotation of the molecule or a change in the rotation state of the molecule. It arises due to change in rotational state. Change in rotational state of molecule. So pure rotation spectra are observed in polar molecules, especially observed in polar molecules. Polar molecules. Which have not permanent electric dipole. These pure polar molecules and the permanent dipole moment permanent dipole moment. Dipole moment. Mainly see here, in case of these polar molecules are the molecules which have positive and negative parts. There is one positive part and negative part. Two separated these molecules called as ಏನಂತ ಕರೀತೀವಿ ನಾವು? We call this as diatomic polar molecule. This is polar diatomic molecule. Polar diatomic molecule. Okay. And this spectra is observed in microwave region. This spectra is observed in what is that? Microwave region. And instead of microwave region, we may have far infrared also. Even in far infrared. FIR ಅಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ. Far infrared. Okay. Far infrared. If both are there, microwave ಇತ್ತು infrared ಇತ್ತು ಎರಡು ಇತ್ತು ಅಂದ್ರೆ there will be only microwave ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದಂದ್ರೆ. Okay, ಆಪ್ಷನ್ ಒಳಗೆ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಂದ್ರೆ we may have in far infrared. Both are there, then there will be only microwave. Okay. The order of the energy associated with the pure rotational spectra. Pure rotation spectra ಇದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಿರುವಂತ ಎನರ್ಜಿ ಅಸೋಸಿಯೇಷನ್ ಏನಿರ್ತದೆ ಗೊತ್ತ್ರಿ? Energy associated with pure rotation spectra. Energy associated will be spectra will be 10 to the power of -3 electron volt. 10 to the power of -3 electron means energy shift that create ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ nearly 10 to the power of -3 electron volt ಒಳಗಡೆ ಶಿಫ್ಟ್ ಆಗ್ತದೆ. So this is what the pure rotation spectra. And moreover pure rotation spectra ಒಳಗೆ ನಾವು ಸಿಂಪಲ್ ಮಾಲಿಕ್ಯೂಲ್ ಯಾವುದು ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ? ಡಯಾಟಮಿಕ್. ಸಿಲೆಬಸ್ ಕೊಟ್ಟಿದ್ದು ಡಯಾಟಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಕೊಟ್ಟಣ. ಡಯಾಟಮಿಕ್ ಅಷ್ಟೇ ನೋಡಿ. ಡಯಾಟಮಿಕ್ molecule. Diatomic molecule ಅನ್ನು ಏನಂತ ನಾವು let us take it as a treat this as rigid rotator. Why we call this one as a rigid rotator? Because as diatomic molecule is a, let us consider one atom here, another one atom here. It is connected by a single bond. So this is one atom. Let's consider this is M2 and this one is M1. As it is going to rotate along this axis, then we are going to treat this one as a rigid. Why we call this one as rigid? The bond is fixed one. Fixed bond, not flexible illa. Idu rigid ada. Those molecules which consist of two atoms is known as diatomic. Diatomic molecules do not show pure rotation spectra because they do not have a permanent dipole moment. Diatomic molecule actually they will not show. But now ಏನು ಟ್ರೀಟ್ ಮಾಡತ್ತಿದ್ವಿ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಡಯಾಟಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಎರಡು ಟೈಪ್ ಬರ್ತಾವೆ. ಡಯಾಟಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಒಳಗೆ ಎರಡು ಟೈಪ್. Two types of diatomic. One is polar, another one is non-polar. So ಯಾವ ತರ polar molecules ಯಾವ non-polar molecules? Wait a second. Is it visible? Yes. So what I was defining, there are two types of diatomic molecules. Two types of diatomic molecules. Diatomic molecule ಎರಡು type ಬರ್ತವೆ. ಯಾವ ಬರ್ತವೆ? One is polar molecule, another one is non-polar molecule. Here let us consider non-polar molecules. Non-polar molecules, they don't have permanent dipole moment. Don't have permanent dipole moment. Permanent dipole moment. Dipole moment. Okay. So polar molecules have permanent dipole moment. So permanent dipole moment. Permanent dipole moment. Permanent dipole moment. Okay. Next, as they do for non-polar and polar molecules. Okay. Non-polar molecules examples have H2, N2, then O2. These are non-polar molecules. In case of polar molecules, they are taken as CO carbon oxide theory, monoxide, Cl theory, or HF theory, hydrogen fluoride, or microwave active. These are on a pure rotation spectrum. So these don't show rotation spectra. Rotational spectra. But these will show rotation spectra. Rotation spectra ne yav toristavo ಏನಂತ ಕರಿತೀವಿ ನಾವು? These are called as microwave active ಅಂತ ಕರಿತೀವಿ. We call that as microwave active molecules. Active molecules ಅಂತ ಕರಿತೀವಿ. Microwave active molecules ಅಂತ ಕರಿತೀವಿ. Clear? Then basically because they have permanent dipole moment ಆಗಿರ್ತಾವೆ ಎಲ್ಲ microwave active ಇರ್ತಾವೆ. And these are called as microwave inactive. Microwave inactive ಅಂತ ಕರಿತೀವಿ. Inactive molecules. So microwave ಅಂತ ಬಂತು ಒಂದು ತಿಳಗಿಟ್ಟುವರೆ it is for pure rotational. So we are talking about pure rotational ಅನ್ನಂಗಿದೆ. Okay. The application of microwave, how these molecules will rotate. ಯಾವ ತರ rotate ಆಗ್ತವ? Microwave is also one of the electromagnetic wave. Electric dipole moment generates this generates when there is a separation of the charges. Electric dipole moment create ಆಗ್ತೈತಿ. Two charges are separated by a certain distance. Let us consider this is a positive charge atom. This is negative charge atom. Let us consider its mass is m2 and its mass is m1. The separation between these two are going to be considered as, let's take r on the distance though. Center of mass point. O. So this is m1 mass, m2 mass. So if it rotates, rotation ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಈ ಕಡೆ ಹೋಗ್ತಂದ್ರೆ ಇದು ಮಾಲಿಕ್ಯೂಲ್ m2 ಏನು ಮಾಡ್ತೈತಿ? ಬರ್ತೈತಿ. For the center of mass they are going to rotate in this direction, isn't it? They are going to rotate in this direction about the center of mass. For example, if I consider CO molecular theory, CO diatomic and O ಅಂತ ಇದೆ. This is minus sign, this is plus sign. Right? They are going to have a finite dipole moment due to the separation between the charges. So ಆ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವೇನು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ? ಮೈಕ್ರೋವೇವ್ ಇನ್ಆಕ್ಟಿವ್ ಅದನ್ನು ಇಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲೇನಾಗ್ತೈತಿ? Electromagnetic wave of microwave region is passed through these molecules. Then the first half cycle m1 goes up and second half cycle m2 goes down. Like ಏನಾದರೂ electromagnetic wave ಅನ್ನು ಪಾಸ್ ಮಾಡಿದ್ವಿ, that is EM wave ಅನ್ನು ಪಾಸ್ ಮಾಡಿದ್ವಿ ಅಂತ ಕರೀತೀವಿ. That is nothing but microwave. Microwave electromagnetic wave ಅನ್ನು ಪಾಸ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ, electromagnetic wave ಪಾಸ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಮಾಲಿಕ್ಯೂಲ್ ಮೇಲೆ ಹೋಗ್ತೈತಿ, ಕೆಳಗೆ ಮಾಲಿಕ್ಯೂಲ್ ತಳಗೆ ಬರ್ತೈತಿ. ಆಟೋಮೆಟಿಕ್ಲಿ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ rotation create ಆಗುತ್ತೆ about the center of mass axis. For position of the particle ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, ಮಾಲಿಕ್ಯೂಲ್ ಹಿಂಗ್ ರೊಟೇಟ್ ಆಗ್ತಿತ್ತು ಅಂತಂದ್ರೆ ಇಟ್ ಗೋಸ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಫಸ್ಟ್ ಗೆ ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಬರ್ತೈತಿ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಹೋಗ್ತೈತಿ. ಸೊ ಸ್ಟೇಜ್ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಜ್ ಏನು ಹೋಗ್ತೈತಿ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಬರ್ತೈತಿ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಹೋಗ್ತೈತಿ. ಇದ್ರ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಜ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಮೇಲೆ ಹೋಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ತಳಗೆ ಬರ್ತೈತಿ. ಲೈಕ್ ದಿಸ್ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು rotate, it is going to change its position. So this is called as ಏನಂತ ಕರಿತೀವಿ ನಾವು, rotation ಅಂತ ಕರಿತೀವಿ. one rotation cycle complete ಎಷ್ಟು ಡಿಗ್ರಿ ತಗೋತದೆ ಇದು, ಮತ್ ಮೈನಸ್ ನೋಡ್ರಿ, ಮತ್ ಪ್ಲಸ್ ಬಂತು, ಮತ್ ಮ್ಯಾಲ್ ಮೈನಸ್ ಹೋತು. ನೆಕ್ಸ್ಟ್ 180, ಈಗ ಸದ್ಯ 180 ಅದ. ದೆನ್ ಅಗೇನ್ ಏನ್ ಮಾಡ್ತೈತಿ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಬರ್ತೈತಿ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಹೋಗ್ತೈತಿ. ದೆನ್ ದಿಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ಇಂಟು ಅಗೇನ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮ್ಯಾಲ್ ಹೋಗ್ತೈತಿ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರ್ತೈತಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅಗೇನ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಟೋಟಲ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರ್ಬೇಕಾದ್ರೆ ಟೋಟಲ್ ಎಷ್ಟು ಡಿಗ್ರಿ ಚೇಂಜ್ ಆಗ್ತೈತಿ, ಇದು 360 rotation ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ, ಒಂದು ಕಂಪ್ಲೀಟ್ rotation. ಈಗ ಅಕಸ್ಮಾತ್ ನಾವು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ ಮೇಲೆ ಏನು ಇನ್ಸಿಡೆಂಟ್ ಆತಲ್ಲ, ಅವಾಗ ಏನು ರೊಟೇಷನ್ ಕ್ರಿಯೇಟ್ ಆಗತ್ತದ, ನೀವು ಅಕಸ್ಮಾತ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡುವಂತ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಏನಾದ್ರು ಹೆಚ್ಚು ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ರೊಟೇಷನ್ ಫಾಸ್ಟ್ ಆಗ್ತದೆ. ಸೊ ಇಫ್ ಯು ಇನ್ಕ್ರೀಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಇಫ್ ವಿ ಇನ್ಕ್ರೀಸ್ that electromagnetic wave, that is microwave frequency ಅನ್ನ increase ಮಾಡಿದೀವಿ ಅಂದ್ರೆ, increase frequency, rotation speed increases. rotational speed ಏನಾಗ್ತದ್ರಿ, ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೆಚ್ಚಾದಂಗ. and frequency, if you increase the frequency beyond microwave region ಹೋದಿವಿ ತಿಳ್ಕೊರಿ ನೀವು, ಆಟೋಮ್ಯಾಟಿಕಲಿ ಏನಾಗ್ತದೆ, ಅದು pure rotation spectra ತೋರಿಸೋದೇ ಇಲ್ಲ. range of frequency changes and reaches its other region like a visible region ಒಳಗೆ ಎಂಟರ್ ಆಯ್ತದ ಅನ್ಕೋರಿ. So if you increase the frequency beyond, if increase the frequency is beyond microwave, then it will not show no rotational spectra. ಇದು ಆಬ್ಜೆಕ್ಟ್ ಬಿಯಾಂಡ್ ಹೋಗ್ತದೆ, ಪ್ಯೂರ್ ರೋಟೇಷನ್ ಹೋಗಿ ಬಿಡ್ತದೆ ಅಲ್ಲಿ, ಮೋಸ್ಟ್ಲಿ ಪ್ಯೂರ್ ರೋಟೇಷನ್ ಹೋಗ್ತದೆ. ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೈಕ್ರೋವೇವ್ ಏನೋ ಮಾಲಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಮ್ಯಾಚ್ ಆಗ್ತೈತಿ, ದೆನ್ ಇಟ್ ವಿಲ್ ಶೋ ಪ್ಯೂರ್ ರೋಟೇಷನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಅಂತ ಕರಿತೀವಿ. ಸಪೋಸ್ ವೆನ್ ಇನ್ಸಿಡೆಂಟ್ ವಿಸಿಬಲ್ ಲೈಟ್ ಆಯ್ತು ಅದ್ರ ಮೇಲೆ ಅಂತಂದ್ರೆ, then it will not show pure rotation spectra because the frequency of the visible light is more than microwave, so they will not match. And moreover ಏನಂದ್ರೆ rotation spectra ಯಾವಾಗ ತೋರಿಸ್ತದಪ್ಪ ಅಂದ್ರೆ, ಇದ್ರ rotation ಒಂದು ಇದನ್ನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರ್ತೈತ್ರಿ, natural rotation frequency ಅಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ. So natural rotational frequency of this diatomic is rotational frequency of diatomic increase ಯಾವಾಗಿದೆ, if diatomic matches with microwave, then ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ, ರೆಸೊನೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ, or we can call pure rotation spectra. purely rotate ಆಗ್ತಿರ್ತೈತೆ ಅವಾಗ. microwave frequency, then it will show pure rotation spectra, pure rotational spectra ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, and here ಹೆಂಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಇದ್ರದ್ದು, how to study about this one? ನೋಡ್ರಿ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನ y ಆಕ್ಸಿಸ್ ಒಳಗೆ ಇಡ್ತೀನಿ ನಾನು. ಈಗ ಕ್ವಶನ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ, ದಿಸ್ ಮಾಲಿಕ್ಯೂಲ್ ವಿಲ್ ನಾಟ್ ಶೋ ಪ್ಯೂರ್ ರೋಟೇಷನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಅಬೌಟ್ ದ ಎಕ್ಸಿಸ್ ಅಂತ ಕೇಳೋಣ. ಸೊ ಎಕ್ಸಾಂಪಲ್ ಮಾಲಿಕ್ಯೂಲ್ ತೋರು, ಡಯಾಟಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್. ಲೆಟ್ ಅಸ್ ಟೇಕ್ ದಿಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, m1 ಮಾಸ್, ಇದು ಕನೆಕ್ಟೆಡ್ ಆಗಿ m2 ಮಾಸ್ ಇಲ್ಲಿ ಅದು. ಸೊ ಇಟ್ ಈಸ್ ಕೆಪ್ಟ್ ಇನ್ along y axis. It is kept along y axis. y axis ಅನ್ನು ಇಟ್ಟಿನಿ ನಾನು, ರೈಟ್. ಸೊ ಈ ಆಕ್ಸಿಸ್ ಅನ್ನು ಏನು ತಗೋತೀನಿ, z ಆಕ್ಸಿಸ್ ಅಂತ ತಗೋತೀನಿ. ಈ ಆಕ್ಸಿಸ್ ಅನ್ನು ಏನು ತಗೋಣ, x axis ಅಂತ ಕರೆಯೋಣ. ಓಕೆ, along which axis it will not show any rotation spectra? Which axis will not show rotation spectra? Which axis will not show pure rotational spectra? ಎಸ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಯಾವುದೇ ಎರಡು ಮಾಸ್ಗಳು ಒಂದು 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 ಡಿಸ್ಟೆನ್ಸ್ ದಿಂದ ಕನೆಕ್ಟ್ ಆಗಿದ್ದು ಅಂದ್ರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಏನು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಲ್ಲ ಆಕ್ಸೆಸ್ವಲ್ ಆಗಿ ಆಲ್ವೇಸ್ ಇದು ಏನು ತೋರಿಸ್ತದೆ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ತೋರಿಸ್ತದೆ ಸೊ ಸೊ along 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 z and y z and x moment of inertia I is nothing but moment of inertia another non-zero I is not equal to 0 along these axes therefore ix is not equal to 0 and iz is not equal to 0 but along y axis another along y axis y moment of inertia is taken as 0 therefore no rotation spectra no rotational spectra anything and moreover rigid rotator ಆಗಿತ್ತು molecule ಬಾಳ rigid ಇತ್ತು ಅಂದ್ರೆ especially that shows for rotation spectra. Yeah, let us consider ಒಂದು ಎರಡು ಮಾಸ್ ತಗೋಣ. Okay, what will take? Let us consider this one mass m1 and m2. One mass m1 ತೋರಿ one mass m2 ತೋರಿ. Okay, as it is rotating about the axis ಈ ತರ ಒಂದು ಕಡೆ ಹಿಂಗೆ rotate ಆಗತ್ತದ ಅನ್ಕೋ. As it is rotating, it is going to possess a moment of inertia. Let us call its moment of inertia I is equal to mr square. ಇಲ್ಲಿ ಮಾಸ್ ಎರಡು ಇರೋದ್ರಿಂದ we are going to take that one as a reduced mass becomes I equal to ಏನು ಬರ್ತೈತೆ ಅದು mu r square ಬರ್ತೈತೆ small mu ಅನ್ನು ಏನು ಬರಿತೀವಿ ನಾವು reduced mass ಅಂತ ತಗೋತೀವಿ that is given by m1 m2 divided by m1 plus m2 ಇದನ್ನ ಇಟ್ಕೊಂಡು I ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. So energy eigenvalue for this rotation spectra is given by energy eigenvalue for the rotational motion can be calculated by solving Schrodinger equation solve ಮಾಡಿದಾಗ ನಮಗೆ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಬರ್ತೈತೆ. But energy of rotation motion, energy of rotational motion, energy of rotational motion is given by Ej is equal to h square divided by 8 pi square into I into j into j plus 1. So this is what actually called as an energy of a rigid rotator. Energy of a rigid rotator. J is called as rotational quantum number. Is called as rotational quantum number. J is going to take the values from. We may take the value from 0, 1, 2, 3 up to infinity. Tana value to hotadu. So J is taken as rotational quantum number. Quantum mechanically defined ಮಾಡಬೇಕಾದ್ರೆ quantum number define ಮಾಡ್ತೀವಿ. The EJ is nothing but jth level energy, or EJ is nothing but jth level energy. Jth level energy. Okay. When J is equal to 0, total energy is equal to 0. Rotational energy of the molecule is quantized. Remember, so this is quantized. This is quantized. Quantized in terms of quantized in terms of from the classical mechanics ಒಳಗೆ energy ಏನು ಬರ್ತದೆ ಗೊತ್ತಾ rotational energy is equal to from classical mechanics over 8 half I omega square ಅಂತ ಬರೀತೀವಿ in classical mechanics. So this is given by Ej is equal to what we wrote there. We wrote h square divided by 8 times of I square times of I into j plus 1 ಅಂತ ಬರೀತೀವಿ. So this is in case of quantum mechanical approach. Quantum mechanics wise ನಮಗೆ ಹಿಂಗೆ ಕಾಣ್ತದೆ. Where this omega is defined as called as angular frequency of rotation. Angular frequency of rotation. So ಅಕಸ್ಮಾತ್ ಇವೆರಡನ್ನು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ನನಗೆ ಏನು ಸಿಗ್ತೈತೆ ನೋಡ್ರಿ. To compare these two is half I omega square is equal to what I wrote here. Half I omega square is equal to is square divided by 8 pi square into I into j into I ತಳಗ ಬರ್ತದೆ j into j plus 1 ಬರ್ತದೆ. ಇದೆರಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಏನು ಸಿಗ್ತದೆ ನೋಡ್ರಿ. ಒಮೆಗಾ ಏನು ಬರ್ತದೆ ನನಗೆ ಒಮೆಗಾ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಹಾಕಿದ್ರಿ I ನು ಮಲ್ಟಿಪ್ಲೈ ಆಗ್ತೈತಿ ದೇರ್ಫೋರ್ ಇಲ್ಲಿ ಉಳಿತೈತಿ ಏನು 2 1s are 2 4s are ಉಳಿತು. ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಅದ I ಸ್ಕ್ವೇರ್ ಆಗ್ತೈತಿ ಕೆಳಗೆ ರೂಟ್ ಹಾಕಿದ್ವಿ ಅಂದ್ರೆ h ಡಿವೈಡೆಡ್ ಬೈ 2 I ಬರ್ತೈತಿ into root over j into j plus 1 ಬರ್ತೈತಿ. Is that clear? So this is what is the angular frequency of the So this is defined as angular frequency of rotation spectra. Rotational spectrum. ನೋಡಿ ಒಂದ್ಸತಿ ನಿಮಗೆ ಒಮೆಗಾ ಸಿಕ್ತು ಅಂದ್ರೆ you know that how to calculate the rotational angular momentum for the rotation motion. Angular momentum for rotational motion. So rotational motion that is given by ಬರಿತೀವಿ L is equal to I omega ಅಂತ ಬರಿತೀವಿ. L equal to I omega. For L equal to I omega ಒಳಗೆ omega substitute ಮಾಡಿದ್ರೆ L equal to value ಏನು ಬರ್ತೈತಿ? That is what was that omega value? Here I wrote above. That is omega is equal to if I write that I into h divided by I into h divided by 2 pi times of I into root over j into j plus 1 ಬರ್ತೈತಿ. So if I cancel I get L is equal to h divided by 2 pi into root over j into j plus 1. So this is what exactly the angular momentum in terms of rotation motion is defined. Similarly, we can define the wave number of the jth level. So it's a angular momentum of jth level. Angular momentum of jth level. Okay, jth level. Similarly, we can define the wave number of jth level also. Wave number. Hang define ಮಾಡೋರು wave number ಅನ್ನ wave number ಏನು ತಗೋತೀವಿ nu bar that is nothing but 1 by lambda is equal to wave number. You can represent this one as a nu bar. You can represent this 1 by lambda from this equation. Energy of the jth level is equal to, can I write that is h nu. I can define this one as hc divided by lambda. So 1 by lambda is equal to ಏನು ಬರ್ತದೆ ನಿಮಗೆ 1 by lambda is equal to j divided by hc ಬರ್ತದ್ರಿ. This is what is nothing but wave number, that is nu. Nu is equal to, we can write that one as j divided by hc. Is it clear? Then if I substitute that ej value, is going to be ej is going to be square divided by 8 pi square into I into j into j plus 1 ಬರೀತೀವಿ divided by c. h cancel ಆಯ್ತು, ಉಳಿತದೆ nu bar is equal to h divided by 8 pi square I into c into j plus 1 ಅಂತ ಕರೀತೀವಿ. This is the nu bar, it's a wave number. See here we are going to take this constant, this value h divided by 8 pi square ic ಐತಿಲ್ಲ, value ಅನ್ನು ನಾವು ಏನಂತ ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ, going to treat that one as b. That is called as b is equal to h divided by 8 pi square times of I into c. So this is called as rotational constant. Rotational constant. ನಾವೇನಂತ ಕರಿತೀವಿ, rotational constant ಅಂತ ಕರಿತೀವಿ. Therefore wave number can be replaced as wave number v is nu bar is equal to, that is b into j plus 1. So this is what is actually nu bar can be calculated using our concept. On the basis of wave number, we can draw the rotational levels. Rotational levels on a wave number basis ಮೇಲೆ ಬರಿಬಹುದು. As the rotational number j increases, then the separation between the levels increases. So what do you mean by separation? Separation means in delta nu bar. Separation is defined between separation can be defined as delta nu bar. Delta nu bar ಏನು ಬರ್ತದೆ ಇಲ್ಲಿ delta nu bar? delta nu bar ಏನು ಬರ್ತದೆ ಹೇಳ್ರಿ? delta nu bar ಏನು ಬರಂಗಿಲ್ಲ, that is going to be actually delta nu bar one state to another state ಬರಿತೀವಿ. delta nu bar ಬರ್ತದೆ anyway ಮತ್ತೆ j ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ ಇದು. So therefore nu bar or separation between the spectral lines directly proportional to j increases, separation increases. ಮೂರು ಬರ್ತೀನಿ ನೋಡಿ. ಡಿಫರೆಂಟ್ ರೋಟೇಷನಲ್ ಲೆವೆಲ್ದಾಗ ಏನಾದ್ರು transitions ಆತು. When the transitions takes place in the rotational levels, then it gives rise to rotational lines. Transitions in rotational level. use rotational lines. Use rotational lines. Rotational line ಗೆ ನಾವು ಏನಂತೀವಿ rotation spectra ಅಂತೀವಿ ಮತ್ತೇನಿಲ್ಲ. Selection rule for rotation spectra J ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ತನಕ ಚೇಂಜ್ ಆಗಬಹುದು one state to another state. If it comes from J plus 1 to ಎಲ್ಲಿ ತನಕ ಜಂಪ್ ಆಯ್ತು ಅಂದ್ರೆ it gives the rotation line ಕೊಡುತ್ತದೆ. ಆ rotation line ಗಳು EM waves ದಾಗ ಇರ್ತವೆ. So selection rule for this quantum is this ಅಲ್ಲಿ ಏನಿತ್ತು angular momentum quantum number ಇತ್ತು atomic number ಒಳಗಡೆ atomic physics ಒಳಗಡೆ. Here molecular physics ಒಳಗಡೆ J is taken as rotational quantum number. Selection rules for rotational quantum number. Selection rules for rotational quantum number. Rotational quantum numbers. So rotational quantum number selection rules. Delta J should be equal to is only plus or minus 1. It is 0 angle re. Rotation spectrum, rotation quantum number ಒಳಗಡೆ 0 ಬರಲ್ಲ. ಇಲ್ಲಿ 0 ಬರ್ತಿತ್ತು 0 or plus or minus 1 ಬರ್ತಿತ್ತು. But ಇಲ್ಲಿ 0 or plus or minus ಏನು ಡಿಫೈನ್ ಮಾಡಂಗಿಲ್ಲ. Only plus or minus ನಟ್ಟ ಅಂದ್ರೆ one state to another state ಅಂತ ಜಂಪ್ ಆಗೋ ಪಾಸಿಬಿಲಿಟಿ ಅದ. ಯಾವ ತರ let us consider J equal to 1 2 3 ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Okay, ನಾವು ಲೆವೆಲ್ ವೈಸ್ ಬರ್ದೀವಿ ಅಂತಂದ್ರೆ in terms of separation between two successive lines is going to be defined in terms of nu bar. Separation between two rotational lines. Between two rotational lines. Two rotational level or rotational lines. Rotational levels are defined in terms of or defined or represented in terms of nu bar. Nu bar form ಒಳಗೆ represent ಮಾಡ್ತೀವಿ. ಹೆಂಗೆ? Let us take that. What is that nu bar we got? Nu bar is equal to P into J plus 1. Correct? Wait. It's P into J plus 1. P into J plus 1. Okay. So this is the nu bar. Let us take as it is at a ground state. J equal to 0 state. If you take J equal to 0, what do you get there? It is going to be nu bar equal to 0B. Nothing but totally 0. Correct? Let us take this is the level. Then second level. If I take J equal to 1, then it becomes nu bar equal to 2B ಬರ್ತದೆ. ಬರ್ತದೆ. Then ಆ ಲೆವೆಲ್ ಅನ್ನು ನಾನು ಇಲ್ಲಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀನಿ. I will represent here. Let us take J equal to 2 ತಗೋರಿ 6B ಬರ್ತದೆ. 6B ಬರ್ತದೆ ಇದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ತೋರಿಸ್ತೀನಿ ಇಲ್ಲಿ ತೋರಿಸ್ತೇನೆ. ಓಕೆ. ನೆಕ್ಸ್ಟ್ ತಗೋರಿ J equal to 3 ತಗೋರಿ. J equal to 3 ತಗೊಂಡ್ರೆ ಅಂದ್ರೆ it becomes 12B. 12B ಅಂದ್ರೆ ಇನ್ನೂ ದೊಡ್ಡ ಬರ್ತದೆ ಮೇಲೆ ಬರ್ತದೆ. ಕರೆಕ್ಟಾ? So let us show this line as here. So little bit ತೋರಿಸ್ತೇನೆ. This line ಅನ್ನು I will show here only. Okay. Want to check this the level difference. What is the difference between these two? What is the difference between these two? What are the differences to V? But what about the difference between these two now? 4B. Then what about difference between these two? Is 6B. Isn't it? Nodi. 2 4B. You know 2 4B. Another. This is the increase in levels. Levels bare, lines bare. Remember, rotational level is different than rotational level is difference between nu bars. Rotational lines ಅಂದ್ರೆ ಏನು? What exactly this rotational lines ಮತ್ತು rotational level ಗೆ ಏನು difference ಅದ? Rotational level ಅಂದ್ರೆ J values. So here 1 minute. Black lines ತೋರಿಸಾತಿದ್ನಿಲ್ಲ ಬೇರೆ ಬೇರೆ ಪ್ಲೇಸ್ ಹೋಗಿ ತೋರಿಸ್ತೀನಿ. One is here, one ಇಲ್ಲೊಂದು ತೋರಿಸ್ನು, next ಇಲ್ಲಿ ತೋರಿಸ್ನು. ಕರೆಕ್ಟಾ? This is 6B ಅದ, difference 4B ಅದ, 2B ಅದ. Once check it, the difference between the J levels, this is J1, J0, J1, J2, J3. ನಡುವಿನ ಡಿಫರೆನ್ಸ್ ನೋಡಿದ್ರೆ ನಿಮಗೆ 6B, 4B, 2B ಬರ್ತಾವ. ಕರೆಕ್ಟಾ? ಲೆವೆಲ್ಸ್ ನೋಡು. What is the separation between two successive rotational lines? Separation between rotational lines. Separation between rotational line. separation between rotational lines. Rotational lines ಅಂದ್ರೆ ಏನು? successive consecutive rotational lines ಅಲ್ಲ. 2b ಗಾದ್ರೆ 4b ಅದ. what is the difference history? What is the difference between these two? 2b. What is the difference between these two? 2b. ಮುಂದೆ ಹೋಗ್ರಿ ಕೂಡ 2b ಅದ difference. 4 rotational lines ನಡುವಿನ difference ಏನು? It always constant that is equal to ಏನಿರ್ತದ? equal to 2b ಇರ್ತದೆ. remember separation levels ನೋಡು separation ಬೇರೆ spectral lines rotational lines ನೋಡು. lines ಅಂದ್ರೆ emitted radiation transition ತಗೊಂಡಾಗ emitted radiation ಒಂದಕ್ಕೊಂದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋದು 2b ಡಿಫರೆನ್ಸ್ ಅದಾವ ಕರೆಕ್ಟಾ. ಲೆವೆಲ್ಸ್ ನೋಡು 3 4b 6b ಡಿಫರೆನ್ಸ್ ಅದ. this is in case of rigid rotator spectrum. and moreover separation between the level increases as j increases. see separation level increase ಆಗೋತ ಹೋಗ್ತೈತಿ. separation between the lines is rotational lines is constant. remember this point, this line is always constant. it is the same thing. separation between rotational levels increases as j increases. That clear? Levels increases as j increases, but rotational lines is always constant, equal to 2b. So this is what is a rigid diatomic molecule. What happens if it is a non-rigid diatomic molecule? Non-rigid diatomic molecule. What happens in non-rigid part? What happens in non-rigid part? Because of this non-rigidity, it is going to experience some part of vibrational also. Some part of vibration. Rotational vibration ಅಂತನೂ ಮುಂದೆ ಬರ್ತೈತಿ. Pure vibration ಅಂತ ಬೇರೆ ಬರ್ತೈತಿ. Then we are going to have different parts. See this. If this is a non-rigid diatomic molecule. This concept is non-rigid diatomic molecule. So non-rigid diatomic molecule. Non-rigid ada. Non-rigid ಅಂದ್ರೆ bond fix ಇರಂಗಿಲ್ಲ. Variation ಆಗ್ತೈತಿ. Separation between the atoms remains constant during a rotation, that is called as rigid rotor. Non-rigid ಅಂತಂದ್ರೆ separation between the atoms does not remain fixed during the rotation. Separation between atoms doesn't remain fixed during rotation. ನಾವೇನಂತ ಕರಿತೀವಿ? non-rigid rotor ಅಂತ ಕರಿತೀವಿ. Molecule will behave as non-rigid rotor. Diatomic molecule is like a dumbbell shape. ಆತರ ಇರ್ತದೆ. diatomic molecule dumbbell shape ಇರ್ತೈತಿ. ಒಂದು molecule ಇಲ್ಲೊಂದು molecule ಅದ. ಎರಡರ separation ಅನ್ನ represent ಮಾಡ್ತೀವಿ. it's a dumbbell shape ಅದು. call this one as dumbbell shape. It is considered like this. So this is separation between the atoms. So it's a dumbbell shape ಇರ್ತೈತಿ. Let us consider this is m1, m2 ಅದ. ಅಕಸ್ಮಾತ್ ಒಂದು particular axis wise ಇದರ rotate ಆಗ್ತಿತ್ತು. if it is rotating like this, rotate ಆಗ್ತಿತ್ತು along the z axis ಅಂತ ಬರುತ್ತೆ. okay. then rotation, centrifugal force will stretch the molecule. ಏನಾಗ್ತೈತಿ? ಇವೆರಡು ಹಿಂಗ್ ಫುಲ್ ಫಾಸ್ಟ್ ಆಗಿ ತಿರುಗೋದ್ರಿಂದ centrifugal force ಏನ್ ಮಾಡ್ತೈತಿ? ಇಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತೈತಿ ಇವೆರಡು ಮಾಲಿಕ್ಯೂಲ್ ಮೇಲೆ. centrifugal force. so this will be centrifugal force ಈ ಕಡೆನೇ ಆಕ್ಟ್ ಆಗ್ತೈತಿ, centrifugal force ಈ ಕಡೆನೇ ಆಕ್ಟ್ ಆಗ್ತೈತಿ. ಎರಡರಿಂದ ಏನಾಗುತ್ತೆ? ಇದು it become stretching create ಆಗ್ತೈತಿ. okay. molecule ನೋಡು. higher the rotational speed, higher the molecule will stretch. higher rotational speed, higher will be the stretch. Will be the stretch. Okay, stretch. Create agutandre FC nodri. FC moment of inertia, sorry, centrifugal force is equal by mv square by r anta ಬರಿತೀವಿ. Velocity increase ಆದಂಗ speed increase ಆದಂಗ force ಏನಾಗುತ್ತೆ ಜಾಸ್ತಿ ಆಗ್ತೈತಿ. ಸಂಬಂಧ ಅದ್ರ ಬಾಂಡ್ ಏನಾಗ್ತೈತಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತೈತಿ. Centrifugal force will stretch the molecule. Okay, then automatically rotational energy ಏನಾಗಿ ಬರ್ತೈತಿ ಅಲ್ಲಿ. Then because of this part, rotational energy changes. Rotational energy changes. Energy changes. ಹೆಂಗ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ ಇದು rotational energy in the form of wave number ಒಳಗ ಬರ್ದೀವಿ ಅಂತಂದ್ರ wave number of the wave ನೋಡಿ ಎನರ್ಜಿ ಅನ್ನ ಇಲ್ಲಿ wave number ಒಳಗ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಜಾಸ್ತಿ maximum time. So wave number of jth level in case of this non-rigid diatomic molecule. For non-rigid diatomic molecule. Non-rigid diatomic molecule. Non-rigid diatomic molecule. So thus nu bar J is equal to B into J plus 1. B into J plus 1 minus D times of J square into J plus 1 whole square. So this is the nu bar of a diatomic non-rigid molecule. B is called rotational constant. B is already in the, so this B gives rotational constant. Rotational constant. Here B gives centrifugal distortion constant. Centrifugal distortion constant. Why it is called as distortion? Distortion constant. So this is called a distortion means it changes the bond or diameter. Distance changes. Distance changes between atoms. Distortion anta ಕರೀತೀವಿ. Moreover, D will be always less than Z. D will be always less than B. Rotation ಕಿತ್ತನು distortion ಸ್ವಲ್ಪ ಇರ್ತದೆ ಭಾಳ ಇರಂಗಿಲ್ಲ. ಅದರ ಸಂಬಂಧ ಈಗ ಎನರ್ಜಿ ಲೆವೆಲ್ ಗಳನ್ನು ಡಿಫೈನ್ ಮಾಡಬಹುದಾ ನೀವು? If you take that energy level, what is the energy level? That is really B into J plus 1 ಅದು. Distortion ಅಕಸ್ಮಾತ್ 0 ಹಾಕಿದ್ರೆ automatically it becomes rigid rotator. Okay. ಈ ಪಾರ್ಟ್ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಬಂದದ್ದು J square into J plus 1 whole square ಅಂತ. 4. ನೀವು J equal to 0 ತಗೊಂಡು ನೋಡ್ರಿ. J equal to 0 ತಗೊಂಡ್ರೆ ನೀವು ಬಾರ್ equal to 0 ಬರ್ತದೆ. Because completely ಅದು ಇದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದು ಇದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದು. Then what about C? What about J equal to 1? So if you take J equal to 1, what nu bar becomes 2B times minus 4D ಬರ್ತದೆ. 2B minus 4D ಬರ್ತದೆ. So that level becomes here. ಇದನ್ನ ಇಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡ್ತೀನಿ. 1 second. Here 1 and here 1. Okay. Next, if I take J equal to 2 to 1 and J equal to 2 to 1, then what is the nu bar? Nu bar becomes 6B minus 36D. ಆ ಎನರ್ಜಿ ಲೆವೆಲ್ ನ ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ತೇನೆ. ನೆಕ್ಸ್ಟ್ ಹಂಗ J3 ತಗೋರಿ. J equal to 3 ತಗೊಂಡ್ರೆ nu bar equal to it becomes 12B minus 144 D ಬರ್ತೈತಿ. ಆ ಲೆವೆಲ್ ನ ಇಲ್ಲಿ ಬರೀತೀನಿ. ಏನಾದರೂ ಇಲ್ಲಿ ಸಪರೇಷನ್ ನೋಡ್ರಿ. If I look at the separation between this one, separation between this, separation between this, ಏನ್ ಬರ್ತಾವ? Completely change ಬರ್ತದೆ. Completely change ಬರ್ತದೆ. ಸರಿ ನೋಡ್ರಿ. ಎರಡು ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು ಬರ್ತದೆ? What is the difference between these two? It's 2B minus 4D. What about the difference between these two? What about this difference between these two? Is 4B minus 32D, isn't it? 4B minus 32B. What about these two? Difference between the level is going to increase there. What about these two? That 6 minus ಮಾಡಿದ್ರೆ 6B ಬರ್ತೈತಿ. 144 to 4 36 ತೆಗೆದ್ರೆ 108 ಬರ್ತೈತಿ ನೋಡ್ರಿ. 108D. These are the separation between the levels. What about the separation between their lines? The rotational lines, separation between rotational lines. Separation between rotational lines. Separation between rotational lines and hang baribodu andra new bar, change in the new bar node. One 2b minus 4d adu. 2b minus 4d. Next to 40b minus 42d adu. Next to 6b minus 108d adu. 108d adu. Separations nodri. Separation between these two. Idon line, no? Idon line ide. There are lines are there. Separation between the lines is different than separation between levels. So let us take this is one line, second line, this is third line. So what is separation between these two now? The separation between these two is b minus 2d. Now 2d minus 28d. What about separation between these two? That is 2b vartati, but minus 76d vartati. Nodri. Separation between the rotation lines is not constant. Is not constant. It is going to change. Both ಎರಡು change ಆಗ್ತವೆ. Separation between the levels change ಆಗ್ತೈತಿ. Separation between the rotation ಕೂಡ change ಆಗ್ತೈತಿ. But separation between the levels is lesser than compared with the rigid rotor. Compare ಮಾಡ್ರಿ. ಅಲ್ಲಿ separation between the levels ಏನಿತ್ತು 2b 4d then 6b ಅಟ್ಟ ಇತ್ತು. But ಇಲ್ಲಿ ಅದ್ರಾಗ ಮೈನಸ್ ಹಾಕೋತ ಹೊಂಟೈತಿ. Therefore, separation between the levels, rotational levels, is less in comparison with rigid rotor level. So non-rigid rotor compare ಮಾಡಿದ್ರೆ non-rigid rotator rotational levels is less. Separation of rotational levels is lesser compared with rigid rotor. Rigid rotator. Is that clear? So this is what exactly non-rigid rotator non-rigid rotator ಇರುವಂತ difference. So this is non-rigid. Okay, non-rigid. That is rigid. Is that clear? Then you need to remember these equations. This is important. This is important. Okay. Now, isotope effect on a rotation spectra. Isotope effect on a rotation spectra. Isotope effect on rotational spectra. Rotational spectra. See, an element may be composed of many isotopes. Like if you have, for example, many elements like C12 O16 other. Correct? If you are having one example, if you have a replacing, for example, C12 one 13C, then oxygen 16 ಅಂತ ಇಡಬಹುದಲ್ಲ ನಾವು. Then automatically ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ used mass change ಆಗಿಬಿಡ್ತೈತಿ. If you take this mass is taken as mu ಅಂತ ತಗೊಂಡ್ರೆ ಇದಕ್ಕ ಏನಂತ ಕರಿತೀವಿ reduced mass of isotope ಅಂತ ಕರಿತೀವಿ. So this is reduced mass. Automatically reduced mass change ಆಗಿಬಿಡುತ್ತೆ. Reduced mass. Then here also the reduced mass. ನೋಡ್ರಿ ಯಾವ್ದಕ್ಕೆ reduced mass ಜಾಸ್ತಿ ಅದ mu I is greater than mu of I is greater than mu. So isotope mass compared with its original element molecule compared actual molecule compared reduced mass of the actual molecule is less than isotope mass of the isotope molecule. Take for example rotational line ಅಂತ ತಗೋರಿ nu bar ತಗೋರಿ nu bar delta nu bar for the delta nu bar is equal to 3 times of ನಾವೇನು ಬರ್ತೀವಿ j into j plus 1 ಅಂತ ಬರೀತೀವಿ. That is j into j plus 1 ಅಂತ ಬರೀತೀವಿ. What we get here 2b ಅಂತ ಬರೀಕಿತನು we know that is h divided by 8 square times of I into c ಅಂತ ಬರೀತೀವಿ. ಅಲ್ಲಿ j into j plus 1 ಅಂತ ಬರೀಬಹುದು. ನೋಡಿ ನೀವು ಮಾಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುವಂತ ಕ್ವಾಂಟಿಟಿ ಯಾವ್ದೈತಿ ಇಲ್ಲಿ ಮಾಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುವಂತ ಕ್ವಾಂಟಿಟಿ ಯಾವುದು that is moment of inertia because I can be written as mu r square ಅಂತ ಬರೀತೀವಿ ನಾವು. So ಅಂತಂದ್ರೆ ಏನಂತ ಬರ್ಬೋದು, ಡೆಲ್ಟಾ ನ್ಯೂ ಬಾರ್ is directly proportional to its moment of inertia and it is directly proportional to mu. Therefore that separation between rotational lines, that is delta nu bar, delta nu bar, delta nu bar of the actual element or isotope divided by delta nu bar of actual element. This is equal to, I can rewrite inversely proportional within the ಏನು ಬರಲಿಲ್ಲ ನಾನು I divided by I ಅಂತ ಬರೀತೀನಿ. It's a moment of inertia of actual molecule. This is moment of inertia of isotope. Is that clear out? Therefore in separation and ಬರೀತೀವಲ್ಲ energy separation, that completely ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ, so that particular moment of inertia ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ. ಐಸೋಟೋಪ್ ಒಳಗಡೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಹೆಂಗ್ ಮಾಡ್ತೀವಿ, ಐಸೋಟೋಪ್ ಒಳಗೆ ಅಂತ ಏನ್ ಬೇಡ, ಅದು ಯಾಕೆ ನಮಗೆ ಗೊತ್ತಾಗ್ತದೆ. ಇದರಲ್ಲಿ ನೋಡ್ರಿ ಸಪರೇಷನ್ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ. ಸಿ ನಾವು ಹ್ಯಾಡ್ ಓನ್ಲಿ ನ್ಯೂ ಬಾರ್ ಅಟ್ಟ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತದ ನಮಗೆ, ಬಿ ಇಂಟು ಏನಂತ ಬರೀತೀರಿ, ಬಿ ಇಂಟು ಜೆ ಪ್ಲಸ್ ಒನ್ ಅಂತ ಬರೀತೀರಿ. ಸಪರೇಷನ್ ಬಿಟ್ವೀನ್ ಟೂ ಲೆವೆಲ್ಸ್ ಹೆಂಗ್ ತಗೋತೀವಿ, ನಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೂಲ್, ಸೆಲೆಕ್ಷನ್ ರೂಲ್ ಫಾರ್ ಜೆ ಏನೈತಿ, selection rule for J is equal to plus or minus 1 ಐತಿ. ಹಾಗಿದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂವನ್ನ J ತಗೊಂಡೆ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಏನಿರಬೇಕು, ಇದು ಎರಡು ತರ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಾಗಿರ್ಬೇಕು, ಪ್ಲಸ್ 1 ಆಗಿರ್ಬೇಕು. So if it goes from J to J plus 1 or if it goes from J plus 1 to J ಅಂತ ಹೋಗಿತ್ತು ಅಂದ್ರೆ new J ಹೆಂಗ್ ಬರೀತೀರಿ, new J rotation wave number of the line is B into J plus 1 ಅಂತ ಬರೀತೀವಿ. What about new bar of J plus 1 state? That is equal to B into J can be written as now J plus 1. Now it is going to be J plus 2. Then if you take the separation between these two, it is given by delta new bar. That is going to be always B times of J plus 1. 2B times of J plus 1. Okay, ಏನಾಗ್ತೈತಿ new bar delta new bar between J equal to 0 to J equal to 1 ಹೋಗಿತ್ತು ಅಂದ್ರೆ ಬರ್ತದೆ ಇದು 2B ಅಷ್ಟೇ ಬರ್ತದೆ. Then if it goes from delta nu bar, or if it goes from J equal to 1 to J equal to 2 ಹೋಗಿತ್ತು ಅಂತಂದ್ರೆ delta nu bar becomes 4B ಬರ್ತೈತಿ ನೋಡ್ರಿ. ಈಗ ನಮ್ಮ ಸಪರೇಷನ್ ಏನದ 2B 4B ಹಿಂಗ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. So that is what we got here. Moreover, delta nu bar ಇಲ್ಲಿ ಬರ್ದಿನಲ್ಲ, moment of inertia ಮೇಲೆ ಅಟ್ಟ ಡಿಪೆಂಡ್ ಅಲ್ಲ, even it mu mass ಮೇಲೆ ಬರಿಬಹುದು, as moment of inertia directly proportional ಅಂದ್ರೆ mu divided by mu I ಅಂತ ಬರಿಬಹುದು, isotope effect. Which one is more here? The typing ತಗೊಂಡೆ ಅಂದ್ರೆ delta nu bar ತಗೋರಿ. For example, delta nu bar of isotope divided by delta nu bar of ಇದನ್ನು ಬರಿತೀವಿ, ಇದನ್ನು B into J plus 1 ಅಂತ ಬರಿತೀವಿ. ಇದರದ್ದು I ಅಂತ ಬರೀತೀವಿ, moment of inertia rotation constant for isotope divided by P of actual element into J plus 1 ಅಂತ. J plus 1 cancel ಆಯ್ತು. Rotation constant of a reduced mass, isotope divided by actual element. I can rewrite that one as I divided by I of isotope. That is also equal to mu divided by mu of isotope. So this is our relation. ಯಾವ್ದು ಜಾಸ್ತಿ ಅದ, we know that mu I is moment isotope the mass ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರುವ ಸಂಬಂಧ they are inversely proportional. So delta nu bar is greater than delta nu bar of isotope. Is that clear? ಹೇಳ್ತಾನ isotope ಇದಕ್ಕೂ ಸಂಬಂಧಪಟ್ಟ ಹೆಂಗ್ ಬರೀತೀವಿ. Okay. ನೆಕ್ಸ್ಟ್ ನೋಡಿ ಇನ್ನೊಂದು ಬರ್ತದ್ರಿ, ಇಂಪಾರ್ಟೆಂಟ್ ರಿಲೇಷನ್ಸ್ ಅದಾವ, ಅದೇನು ಭಾಳ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಂಗಿಲ್ಲ, ಬರೀ ಫಾರ್ಮುಲಾ ಅದನ್ನ ತಗೋರಿ. ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಾಗ ಅಂತಂದ್ರೆ ನಮ್ಮ ಪಾಪ್ಯುಲೇಷನ್ ಆಫ್ ಜೇತ್ ಲೆವೆಲ್ ರೋಟೇಷನಲ್ ಲೆವೆಲ್, ಪಾಪ್ಯುಲೇಷನ್ ಆಫ್ ಜೇತ್ ರೋಟೇಷನಲ್ ಲೆವೆಲ್ ಅಂತ ಬರ್ತದೆ. ಫಾರ್ಮುಲಾ ತಗೋರಿ. So shall I continue that vibration spectra in tomorrow's class? Morning ತಗೊಂಡೆ ಅಂದ್ರೆ ಮುಗಿತೈತೆ ಅದು. ಸೊ ವೈಬ್ರೇಷನಲ್ ಮುಗೀತು ಅಂತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ವೈಬ್ರೇಷನಲ್ ಬರ್ತೈತಿ. ಅಲ್ಲಿ ಫೈನ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ IR ಬರ್ತೈತಿ ರೇಡಿಯೇಷನ್. ನೆಕ್ಸ್ಟ್ ರಾಮನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಮುಗಿಸ್ತೀವಿ ಅಂದ್ರೆ ಮುಗೀತು. ಸೊ ನಾಳೆ ಈವ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಒಳಗೆ ನಾ ಲೇಸರ್ ನಾಳೆ ಈವ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಮುಗಿತೈತಿ ಮಾಲಿಕ್ಯುಲರ್. ನೆಕ್ಸ್ಟ್ ಲೇಸರ್ದೊಂದು ಅದು ಒಂದು 2 ದಿನದ್ದು ಒಂದಿನ ಮುಂಜಾನೆ ಒಂದು ಈವ್ನಿಂಗ್ ಒಂದು ಕ್ಲಾಸ್ ತಗೊಂಡು ಲೇಸರ್ ಮುಗಿತೈತಿ. ಸೊ ಇನ್ನೊಂದು 2 days ಒಳಗೆ ಮುಗಿತೈತಿ ನೋಡಿ ವ್ಯಾಲ್ಯೂಮ್. ಸೊ ಇದಕ್ಕೊಂದು 2 ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ ತಗೋರಿ. ಏನಂತಂದ್ರೆ population of jth rotational level relative to the ground, relative to ground population, ground level. This is given by n of j, number of population of electrons or transitions, divided by n naught ground. That is equal to 2j plus 1 times exponential of is minus bhc into j plus 1 divided by kbt ಅಂತ ಬರೀತೀವಿ. That is actually 2j plus 1 is nothing but degeneracy of jth level. Degeneracy of jth level. Okay. Actually, term ಎಲ್ಲಿಂದ ಬರ್ತು ಗೊತ್ತೇನ್ರಿ? ಮ್ಯಾಲಿನ್ ಟರ್ಮ್. This term comes from E2 minus E1. ಅದನ್ನ ಎನರ್ಜಿ ಫಾರ್ಮ್ ಒಳಗೆ ಬರ್ತೀವಿ ಅಂದ್ರೆ ಇದೇ ಏನ್ ಬರ್ತದೆ ಗೊತ್ತೇನ್ರಿ? N2 divided by N1. ಮ್ಯಾಲಿನ್ ಸ್ಟೇಟ್ ಮತ್ತು ಕೆಳಗಿನ ಸ್ಟೇಟ್ ಅಂತ ಎನರ್ಜಿ ಲೆವೆಲ್ ಹಿಂಗ್ ತೊಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ here that is exponential of there is minus E2 minus E1 divided by kBT times. So this is population. ಇದೇನು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಿಲ್ಲ. ಒಂದ್ ಸದ್ಯಕ್ಕಂತೂ ನಮ್ಗೆ ಸಂಬಂಧ ಇಲ್ಲ. ಮುಂದಿನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಪಾರ್ಟ್ ಒಳಗಡೆ ಎಲ್ಲಾರು ಬಂದ್ರೆ ನೋಡಿ. ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ rotational partition function ಅಂತ ಒಂದು ಬರ್ತೈತಿ. ಎರಡು rotation spectrum ತಗೊಂಡ್ಬಿಟ್ಟವ. ಅದು rotation function. Rotational partition function. That is going to be Q of R is equal to kBT times kBT divided by HCB. It's called as rotational partition function. ಸದ್ಯಕ್ಕೆ ಇದನ್ನೇನು ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಬಟ್ ಹಂಗೆ ಕೇಳಿದ್ರೆ ಅದು ನೆನ್ಪಿಟ್ಕೋರು ಅಷ್ಟೇ. rotational partition function. Next is vibration spectrum. Vibrational spectrum. Your rotational rigid and non-rigid ಆಯ್ತು. ಈಗ rotation spectrum ನೋಡೋದು. Shall I take that rotation spectrum in tomorrow's class, morning class? Or ಈಗ ಕಂಟಿನ್ಯೂ ಮಾಡಲಿ ಏನೋ 9 ತನಕ ಹೆಂಗೆ ಹೇಳ್ತೀರ ಹೆಂಗೆ?
Tomorrow.
Okay then. Take tomorrow morning vibration spectrum ಮುಗಿಸ್ಕೊಂಡು ನೆಕ್ಸ್ಟ್ ಈವ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಬಂದ ವೈಬ್ರೇಷನ್ ರೋಟೇಷನ್ ಒಂದು ರಾಮನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಒಂದು ನಾಲ್ ಮಾಲಿಕ್ಯುಲರ್ ಡಮಾರ್ ಮುಗಿಸ್ಕೊಂಡು. ಓಕೆ.